Welcome to part 3 of solving the higher GCSE paper 2020. So we have a square root of 1.44 times y. Yes. Then you get square root of 1.44. Then you have a square root of y here. So you have 1.2 square root of y. And that is an increase of 20%. Yes. There you go. That's done. Now we're going to go on to question 19. Yes, we're going to go on question 19. It's a function. So we're going to have g. It says find g of 5. So we're going to just plug in 5. So as you know, this is really simple. We're going to just substitute 5 in all the x's. Okay, so we're going to have this. So we're going to get g of 5 is that's gonna be 10, so 11, 33, done. Okay, next we have find gf of 9, and we have two functions combined. We'll have to solve the inside part first, so we're gonna have to do f of 9. Okay, so f of 9 is gonna be 12 divided by square root of 9. Okay, because we're substituting that in. And that's just gonna be square root of 9 is 3. 12 divided by 3 is 4. Okay, and now it says, now we're going to do the g function. We're going to have g of 4, then, okay, then we're going to do g of 4, which is going to be 3 times 2 times 4 plus 1. So 8 plus 1 is 9. That's going to be 27 then. Okay, there you go. Now it says find the inverse, so we're going to do 6 is equal to 3. So we're going to have 6 is equal to 3 times 2x plus 1. So we're going to get 6 is equal to 6x plus 3, and x equals 2.5. So what we basically just did is we made an equation, right? We put the 6 in here. Right, question 20. It says, show that the square root of 180 minus the 2 square root of 5 divided by 5 square root of 5 minus 5 can be written in the form a plus square root of 5 divided by b, where a and b are integers. The first thing to do with this question is we can rewrite the square root of 180 as square root of 6 squared times 5. Okay, that is equal to the square root of 180 basically. Now the square root of 6 squared is just going to give us 6, and that is just going to leave us with 6 square root of 5. Then now put this all together. It's minus 2 square root of 5 divided by 5 square root of 5 minus 5. Okay, we have the same numbers inside the roots, so we can just take away these two numbers. We're going to get 4. Then we're going to get 4 square root of 5 divided by 5 square root of 5 minus 5. Now what we're going to do, now we want to get rid of the roots, right? We just want numbers on the bottom. It's going to times both sides by 5 square root of 5 plus 5. Okay, both sides. Going to do this. Next thing we're going to get is we're going to get 20. So we're going to get 4 square root of 5 times 5 square root of 5 plus 5. We have the same numbers inside here and here, so we're just going to times them together, going to give us 25, okay? Square root of 25 is going to be 5. So in short, we're going to get 20 times 5, because we did 4 times 5, plus 20 square root of 5. Alright. Now, what we're gonna get divided by, when we do this, this will all cancel out. The root will cancel out. So on the bottom, we're gonna get 25 times 5 plus 25 square root of 5 minus 25 square root of 5 minus 25. Doing that, it's gonna give us 100 on the bottom, divided by 100. and 100 on the top. 100 plus 20 square root of 5. Because we have one term at the bottom, we're just going to get 100 divided by 100 plus 20 square root of 5 divided by 100. We're going to then get 1 plus square root of 5 divided by 5. Yes. And that is a vector question. These are quite nice because they're really actually simple to understand. So it says P is the midpoint of F and D. P is the midpoint of F and D, right there. It says Q is the midpoint of D and E. FD equals A. F to D equals A. Okay, I'm going to do A. This is A. And F to E equals B. Use the vector method to prove that PQ, this line right, so PQ, to prove that PQ is parallel to FE. Okay. So what we're going to do is we know that DE, the vector D to E, there you go. Now we are right there. So now that is D to E. Alright. And now it says, now we're going to do D to Q. D to Q is, so D to Q, this right here, what we're going to have to do basically, so just to make things clear, this is going to be a half A and this is going to be a half A. We're going to, a half A, so we're going to go up, so we're going to have negative a half, because we're going up, then we're going to have plus, okay, we're going to have negative half A, remember to put the A, plus, right there, that's it says Q is the midpoint of D to E, so that is just a half B. Okay, we're going to get a half B. And then what we're going to do is we have P to Q, now that vector right there is really just equal, so P to Q is going to equal, right, a half of A minus a half of A plus a half of B. Simplifying that, this will just cancel out. You're going to get equal to half B. P to Q is equal a half of FE, and therefore they are parallel. That's question 21 done. Question 22, a really long one, a really good question, okay? So, question 22 is the second last question. Okay, this is going to be a really, really long one. The area of A. Okay, the area. So, let's just put it right here because we're going to need a bit of space. The area of A. Okay, the area of A. So, if you know the sector formula, we're just going to do 445. Okay, we're going to do 45 divided by 360 degrees times pi of 5x minus 1 squared, and we're going to minus that from the area of the smaller region, going to be 445 degrees divided by 360 times pi times 3x minus 1 squared. The area of B, the area, we'll have to go even. For the area of B is pi, okay, is pi times 1 minus x squared. You're going to get then what you're going to get next is going to get 45 degrees divided by 360. So we're going to get pi 15x minus 1 squared minus 3x minus 1 squared is equal, right? This is equal to the area of B, which is pi 1 minus x squared. But the pi's, we can cancel them out. So you're just going to get 1/8 of 15x minus 1 times 5x minus 1 minus 3x minus 1 times by 3x minus 1 is equal to 1 minus x times 1 minus x. Okay. Gonna go zoom even further in. Let's now expand. Okay, so this 15 times, okay, we're gonna get 25x squared minus 10x plus 1. Let's put a bracket here. Minus 9x squared minus 6x plus 1 equals to 8 times 1 minus, wait, let me go back. Yeah, 2x plus x squared. Oh, this is this, we're gonna need a lot of space for this one. All right. So minus the x squared and the common terms, we're gonna give us 16x squared minus 4x equals, zoom in, equals 8 minus 16x plus 8x squared. Well, what does this look like? Quadratic. So what we're gonna do, we're gonna take everything to one side, which is gonna give us 8x squared plus 12x minus 8 equals 0. Now we can simplify this further to make this equation easier for us. We can go 2x squared plus 3x minus 2 equals to 0. All I just did there was divide that by 4. So we're gonna give us, so this, I like to use a very simple trick to solve these quickly. I just make a grid. So I have 2x squared here. We're gonna have x, and we're gonna have 2x and an x here. Put the last number, so minus 2, and then put the x, so 3x right here. To make minus 2, we need a 2 and a minus 1. And we're gonna times this by the other number in the grid, so we're gonna get 4x, and you're gonna get minus x, and then we're gonna add them. So 4x plus or minus x plus or minus x is just, 3x. And that is correct. So this works. So we're just gonna highlight this grid over here. We're gonna have 2x minus 1 times x plus 2. Okay, this is a really messy. We're gonna have 2x minus 1 times x plus 2 equals 0. Okay, 2x minus 1, add 1 to both sides, divide by 2, so it's going to give us x is equal to a half. Or minus 2 both sides, minus 2. Okay, now, knowing this, we cannot have a negative. This answer doesn't even matter. Our real answer is just x is equal to a half. That was a very long one, but there we are. Question 23. So we have black shapes, and then we have the ratio to white shapes, and there we are. The ratio to them is a 3:5 ratio, right? What we can do right now is we can times both sides by, let's see, we can times both sides by 9. Okay, we times both sides by 9, gonna give us 27 to 45. Now to circle to triangle, we have the ratio of 2 to 7, if I'm not mistaken, yes. And we're gonna times both sides by 8. It's gonna give us 16 to 57. Okay. As you can see, we have a 27 here, and we want to express it in a total as a fraction of total number of cards with a triangle of the 56. And so our fraction is going to be 27 divided by 56. There you go. Not that hard as the last one, as it was just only 3 marks. However, this question was a really messy one. If you are interested, this is in fact, the 2020. So this is in fact the 2020 paper. Paper 1, non-calculator higher tier. As you can see, however, this question was really messy. I sped through it a lot. So if you have any questions about question 22, you can leave it in the comments and I'll try to answer. For now, hope you guys enjoyed these 3-part series of solving the GCSE exam, and I'll see you all in the next video. Goodbye.